Hello. In this section of our Arduino robotics coding tutorials, we will learn the usage of the Millis function. The Millis function tells us how much time has passed in milliseconds since the moment the program on the Arduino board started running. This function is extremely useful for keeping track of time without stopping the program. However, it's important to note that after approximately 50 days, the value returned by Millis resets back to 0. This happens because the Millis function has a limit based on the Arduino's 32-bit system, and after that much time, it overflows. Whenever we call this function, it gives us the exact number of milliseconds the Arduino has been running since it was powered on or reset. This is really helpful for operations that require precise timing, like controlling LEDs, motors, or tracking events in a project. And since it doesn't interrupt the program's execution, the Arduino can continue running other operations simultaneously, making it a very efficient way to manage time in projects that require multiple actions to be performed at once. When we write unsigned long start time equals Millis, we are creating a variable that will store the value returned by the Millis function. Since Millis returns the time in milliseconds, the value can be much larger than what a regular integer or float can hold. The unsigned long data type is used because it can store much larger numbers up to about 4 billion milliseconds, which equals roughly 49 days. If the Millis function returns a value like 4 billion milliseconds, this is well beyond the limits of integer or float. So, when we use unsigned long with Millis, we can safely store time values that may represent several days without worrying about overflow or errors. This allows us to accurately track time over long periods in our programs. The Millis function does not take any parameters. Unlike the delay function, where you specify a value inside the parentheses to set the delay time, Millis simply returns the amount of time that has passed since the Arduino was powered on or reset without requiring any input from the user. To make an LED blink at regular intervals, we can rely on the Millis function instead of the delay function, and this choice can bring a significant advantage in many situations. When we use the delay function, the Arduino becomes unresponsive for the entire delay period. During this time, it's unable to perform any other operations, no matter how important they may be. It's like the Arduino enters a temporary standby mode, unable to react to anything else happening in its environment. This limitation can be problematic, especially in projects where the Arduino needs to handle multiple processes, such as monitoring sensors, controlling devices, or responding to user interactions. In contrast, the Millis function operates very differently. Instead of halting the program, it simply provides the amount of time that has passed since the Arduino was powered on or reset. This allows us to manage timing without disrupting the flow of the program. This makes Millis a powerful and efficient tool for creating more responsive and dynamic programs. The Millis function is a useful tool for making an LED blink at specific intervals. Unlike the delay function, which pauses the entire program for a set amount of time, Millis allows the program to continue running without any interruptions. This means that while the LED is blinking at regular intervals, the Arduino board can still carry out other operations, such as reading sensor data, controlling motors, or responding to user inputs. The Millis function can also be a valuable tool for evaluating the performance of the Arduino's operations. For instance, it can measure the exact time it takes to execute the commands within a specific section of the program. By doing so, we can identify how much time the program spends in that part of the process and determine if any unnecessary delays are occurring. This insight allows us to optimize the code and take necessary precautions to improve efficiency. Whether for troubleshooting or refining the program, Millis provides a simple yet powerful way to analyze time-related aspects of the system. The Millis function can be used to accurately measure a player's reaction time in a game scenario. By recording the time at the start of an event and then again when the player responds, we can calculate the difference between these two values. This allows us to determine how quickly the player reacted. This method is particularly useful in games or interactive applications where precise timing is crucial for tracking performance or improving gameplay experience. We are moving forward in our education with the help of a sample application. A red LED is connected to pin 13 of the Arduino, and we will use the Millis function to toggle this LED on and off at specific intervals. Connecting an external LED to pin 13 on the Arduino is optional, as the built-in LED labeled L is already linked to pin 13 and mirrors its behavior. Therefore, you can perform the application using the Arduino's built-in LED without needing to connect an external LED. We will observe the operation of the application both through the Tinkercad and physically by inspecting the hardware. Let's move on to the code section. In the setup part, we first initialize serial communication. Serial dot begin at 9600 baud rate. Next, we'll display the value of the Millis function in the setup block. Serial.println Millis function. We print the value returned from the Millis function to the screen by writing this statement. We mentioned that the Millis function provides the elapsed time in milliseconds from the moment the program starts running. Let's start simulation. When we open the serial monitor, we observe the value 1. Stop the simulation and start it again. Again, we see the value 1, indicating that the processing of the command took 1 millisecond. Let's also examine this physically and see if the command is executed in 1 millisecond there as well. Now, we are connecting the Arduino to the computer. As you can see, information about Arduino Uno has appeared on the COM port. We have copied the commands we wrote in the Tinkercad to the Arduino IDE. Serial Monitor panel is visible here. If you don't see this panel, you need to select Serial Monitor from the Tools menu. Now, let's upload the commands to the board. Commands have been successfully uploaded to the Arduino board, and we can see the value 0 in the serial monitor. Reset the board and verify the data in the serial monitor. While in the simulation application, we observed the value returned from the Millis function is 1 millisecond. In contrast, during our physical application test, we see it as 0. As a result, there is no delay in executing the command serial begin 9600. Yet, in the simulation application, it seems like there is a 1 millisecond delay during the execution of this command. There might be situations where you need to use the Millis function in the setup block. For instance, we might want to measure the duration or performance of commands executed at the beginning of the program. During the delay intervals generated with delay command, Millis continues its counting process. For instance, let's introduce a delay of 2000 milliseconds here, and then let our Millis function run. Copy the Millis function here. Paste it on a line below. Add another delay in between. This way, we can monitor how the Millis function operates during these waiting periods. We will make it 500 milliseconds. Then upload the commands to the Arduino board. Let's switch to the serial monitor. The commands are being compiled and loaded. As you can see, the Millis function also operated during the wait times, and after the 2000 milliseconds delay, the Millis function indicated the runtime of my program. Subsequently, after the 500 milliseconds duration, the Millis function again indicates the runtime of the program. When operating in the binary number system on a computer, the value of 1024 corresponds to 1 second, but due to the alignment with 1000 milliseconds in our daily lives, there can be a slight mismatch in numerical values. Certainly, there is software-based synchronization, but you see, there is 1 millisecond deviation in this context. If you are not developing an application where 1 millisecond is crucial, this situation may not pose a significant problem. However, if you intend to perform highly sensitive operations, using the micros function instead of Millis would be more appropriate. Now, let's examine the operation of the Millis function in the loop block. Firstly, we initialize the serial communication at a baud rate of 9600 to display information. Then, in the loop block, we use the serial println Millis expression to ensure that the value obtained from the Millis function is printed line by line on the serial monitor. In this program, if you wish, you can ensure that the data written to the serial monitor is first stored in a variable. I mentioned at the beginning that we need to declare a variable of type unsigned long. I am creating a variable named time here and setting its initial value to 0. Then, in the loop block, assign the value returned from the Millis function to the time variable. Subsequently, the serial print line command will continuously display the value of the Millis function within the time variable on the serial monitor. Let's make sure our commands are loaded onto the Arduino board. As you can see in the serial monitor, the program's runtime is continuously displayed in milliseconds from the beginning. We have completed our theoretical training on the Millis function, and subsequently, we analyze the values returned by the Millis function in the setup and loop blocks. Until our next session, take care.